Alright guys, we have another question from the third chapter of the Meriam textbook, Statics. And in this one, in order to facilitate shifting the position of a lift and hook when it's not under load, the sliding hanger is used. So the projections at A and B engage the flanges of a box beam when a load is supported and the hook projects through a horizontal slot in the beam. And the question is asking us to compute the forces at A and B when the hook supports a 300 kilogram mass. So first of all, we're going to have two reactions at A and B. But we're going to assume that there is no friction at these two supports. So it can freely move in X direction if you just call our X and Y in here. So if we just draw the free body diagram for this part, we obviously have the normal force at A and B. And at this point, we have the weight of this 300 kilogram mass. So we're going to have 300 times 9.81, which is our G on Earth, meter per square second. And this is going to give us the force in Newton. We are in equilibrium. We have three different equations. Sum of all forces in X equals 0. Same for the Y. And we have another equation for the moment, which means we can find up to 3 unknowns in here. But since we don't have any force in X direction, so this one is out. And if we just do the sum of all forces in Y, we're going to end up with A and B. So 2 unknowns, and we're going to go with our moment equation about point either A and B, or it doesn't matter. And counterclockwise positive as always, and we're going to have the 2D shortcut for finding the moment. We have the moment of B about A, which is a clockwise moment, so negative B times the distance from A, or I should say vertical distance from A to the line of action, which is 600 millimeter. We can do the unit conversion for the millimeter, but it won't make any difference in here. So we can just leave it as it is. And we're going to have the moment of weight about A, which is counterclockwise, so positive 300 times 9.81, and the distance would be, again, the vertical distance from A to the line of action, which is 400, and this will be equal to 0. And that's actually why I didn't do the unit conversion, because if we just divide these by 1000, it won't make any difference. So our B would be basically, we can cancel these actually, 200 times 9.81, so 200 times 9.81, which is going to be 1962 newtons, or 1.962 kilonewton. That's our A, and we just do the sum of all forces in Y direction. Should be able to find the B. So we're going to have A minus B, 1962, minus the weight, which was 300 times 9.81 equals 0, and just have to add this to 300 times 9.81, and our A will be 4905 Newton, or 4.905 kilonewton. And the final answer for this question. Hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next video. Have a good one.